Okay, so have you ever been in, say, a huge command center or university, and you see this giant cutting-edge video wall?
Oh, yeah. And you just know the IT team is somewhere in a back room, absolutely losing their minds.
Exactly, hyperventilating
Yeah.
because the AV system just, flooded their entire network backbone.
It's that classic AV versus IT turf war, right? You want perfect 4K video, they want a network that can still send an email.
Right. But today, we're looking at a piece of gear that might just be the peace treaty in that war.
Mm.
We're doing a deep dive on the Kramer KDS-100DEC.
Ah, yes. The open standard low latency AVoIP streaming decoder. That's a mouthful.
It is, but that open standard part is doing some serious heavy lifting here.
It really is, because usually with AVoIP at this scale, you're talking about a completely proprietary system. You're locked in.
Forever. One vendor's encoders, one vendor's decoders.
Yeah.
But here, Kramer is leaning into H.264 and H.265.
Which, basically commoditizes the stream. It means this little box can play nice with all sorts of generic streams.
Not a walled garden.
Exactly. And that's so important when you look at who this is for. We're talking university campuses, big enterprise offices, and even defense facilities.
And the scale they're pitching is, well, it's just wild. The spec sheet mentions support for up to 1,000 video sources.
1,000. That's the big headline number.
But, okay, I have to be the skeptic for a second. If I'm an IT director and you tell me you're about to dump 1,000 4K sources on my network, I don't care how open it is, I'm just picturing total network meltdown.
That's a fair point. A totally valid fear. But that's where the efficiency part of this comes in. This isn't uncompressed video just blasting out.
So what are we talking Y trait-wise?
It operates between 1 and 60 megabits per second.
60 megs. Okay, so at the top end, that's actually manageable on a standard 1 gigabit IT network.
Precisely. You don't need to rip and replace your entire switching infrastructure or build a whole separate AV network just to keep things running.
It just rides on the existing pipes, copper or fiber.
Yep. And it's still handling 4K at 60 hertz. It takes a 4.4.4 input and streams at 4.2.2, so you're not really seeing a massive hit to visual quality for all that bandwidth savings.
But there's always a trade-off. Compression means processing time. It means latency.
You would think.
And in a command and control room, I can't have a 2-second delay.
Well, this is the other key stat. The end-to-end latency is clocking in at around 40 milliseconds.
40. So effectively real time for human perception.
Exactly. It's in that sweet spot. It's
Yeah.
efficient enough for the network admin, but it's fast enough for the operator who needs instant feedback.
And it still carries control signals.
RS-232 and CEC all over IP, so you're not losing that device control.
Okay, let's circle back to something you mentioned, defense facilities.
Right.
If I try to put a normal AVoIP box on a secure government network, the security officer is going to laugh me out of the building. Most AV gear is, well, it's a security nightmare.
And that's where Kramer is really trying to set this apart. The spec sheet reads more like an IT endpoint than an AV box.
What do you mean?
We're talking 802.1x authentication, HTTPS TLS encryption, full compliance with OWASP Pay-10 security standards.
So it's actually hardened for a real enterprise network.
It's built to be a secure node, not a vulnerability. It's really the only way you get approval for these kinds of deployments anymore.
So what about the physical side? The installer's experience?
It's pretty versatile. You've got your standard RJ45 for copper, or an SFP cage if you want to pop in a fiber module for long runs across the campus.
And power. Please don't say it's another wall wart.
It supports PoE plus power over Ethernet.
Ah, thank you. That simplifies things so much. No local power bricks cluttering up the back of the display.
You can use a 12-volt adapter if you really want to, but in a large deployment, you're using the switch for power every time.
So to pull it all together, we have a decoder that essentially builds a bridge between very demanding 4K AV and very strict IT security.
And it does it all while being light enough on the network to run on the existing infrastructure.
It kind of makes the whole convergence of AV and IT boring.
Yeah.
In a good way.
In the best possible way. It's designed to just work securely, efficiently, and at scale.
Which, leaves you with a pretty big question for the industry. If we can now reliably and securely push thousands of low-latency 4K streams over a standard gigabit network, are we finally watching the end of the proprietary hardware-based matrix switcher?
I think the writing is on the video wall. The future is just data packets on a standard network.
Something to think about. Thanks for joining us for this deep dive.